Now, let's make your life a little bit simpler. We're going to discuss the product rule. What do you do when you have two functions that are multiplied by each other and you want the derivative? So let's just say I have some f of x times g of x. All right, and in this case, f of x is 2x plus x squared, and g of x is 7x cubed minus 1. Now, you can do this the long way without the product rule. So I'm just going to rewrite h of x, and I'm just going to expand this. All right, so this is 14x to the fourth. All right, minus 2x plus 7x to the fifth minus x squared. So the derivative of h with respect to x is, let's see, this is 56 x cubed minus 2 plus 35 x to the fourth minus 2x. Now this one wasn't too bad. However, they're not always going to be that simple. We have a product rule which tells us quite simply that if I have two functions that are multiplied by each other and they're both differentiable, then the derivative of that product is equal to the first times the derivative of the second plus the second times the derivative of the first. Now I'm going to derive this for you. Be able to do this on a test or quiz. All right. If I were to take d dx of f of x, g of x, that is the limit as delta x goes to 0 of, let's see, my function in this case, h of x, is f of x, g of x. Okay, so it's going to be the limit of h of x plus delta x minus h of x divided by delta x. All right, so I'm going to take the limit as delta x goes to 0 of, let's see, the first term is f of x plus delta x times g of x plus delta x minus f of x, g of x, all nicely divided by delta x. Now I can add 0, and I will not change this function at all. So what I'm going to do is I'm going to rewrite this as a limit as delta x goes to 0 of f of x plus delta x, g of x plus delta x. And way over here, I'm going to put minus f of x, g of x. And in the middle, I'm going to add 0. And by 0, I mean I'm going to add, and I'm doing this because I know it's a trick. All right, it's a trick that works. I'm going to add f of x plus delta x times g of x. Now if I add it, I have to subtract it. Now I'm going to do this one in green because I'm going to color code these for you so you don't get too lost. Well, I added that one, so I have to add this one. F x plus delta x times g of x. All right, let's look at the first term. Now what we're going to do is we're just going to take the limit equals, come on, pen's not working, limit as delta x goes to 0 of this whole big mess. All right. Now let's rewrite things. I'm going to do the first one in red. If I look at the red, I'm going to factor out f of x plus delta x. So this is f of x plus delta x times, what am I left with? G of x plus delta x minus g of x. Now I'm going to break this up, and I'm just going to put delta x right here, and you're going to see why in a minute. Now to that, I'm going to add this part right here. Now what do I have in common here? Here I have the g of x's are common, so I'm going to factor out g of x, and I'll multiply that by f of x plus delta x minus f of x divided by delta x. All I've done is distribute. I've just broken up into two fractions. Now, do you see by writing it this way what I've done? This literally becomes, let me switch back to black, the limit, apparently I'm not switching to anything, as delta x goes to 0 of, let's look at the first one. This is f of x plus delta x times the limit as delta x goes to 0 of g of x plus delta x minus g of x all over delta x. And then I'm going to switch to green here, and we have to write kind of small here, plus the limit as delta x goes to 0 of g of x times f x plus delta x minus f of x, I'm out of room there, divided by delta x. I think you see what I'm doing here. What does this first one become? This becomes, come on, the limit as delta x goes to 0 of, well, this is just f of x plus delta x. But what does this term right here become? This is just g prime of x. And what does this one right here become? The limit of g of x, this is just g of x times the derivative of f of x. So as I take the limit as delta x goes to 0, I get, well, this is just f of x, g prime of x, plus g of x, f prime of x. Be able to do that. Now let's do the same problem we did before. All right, we're going to let f of x equal 2x plus x squared, and g of x equals 7x cubed minus 1. So f prime of x is 2 plus 2x. G prime of x is 21x squared. Did I do that right? All right. So the derivative of h prime of x is f g prime plus g f prime. So this is 2x plus x squared times g prime, which is 21x squared, plus g, which is 7x cubed minus 1, times f prime, which is 2 plus 2x. Okay, now I know this doesn't seem like I'm saving you steps, but really, in the future, we will be. All right. This is a math class, so please don't leave it that way. That's 41x cubed plus 21x to the 4th plus 7 times 2 is 14x cubed plus 14x to the 4th minus 2 minus 2x. If we collect like terms, okay, this becomes 35x to the 4th. Where's my cube terms? 41 plus 14 is 50. Is that right? 55x cubed minus 2x minus 2. And if we're good, that's exactly what we found before. Now, do the problems and finish your homework when you're done. Now, I don't know if any of you caught this, but I certainly did. Apparently, I cannot multiply. 2 times 21 is not 41, it's 42. So if I make this 42, 42 plus 14 is 56. X cubed. Now it agrees with the problem we did before.